In this video, I will explain how to calculate the marginal rate of substitution given a utility function. So if you are given a utility function, you can calculate the marginal rate of substitution, abbreviated as MRS, by simply taking the marginal utility of x and dividing that by the marginal utility of y. Now, the marginal utility of x, that's calculated as the derivative of the utility function with respect to x. And the marginal utility of y is simply the derivative of the utility function with respect to y. So I have three different utility functions here. I'm going to show how to calculate the marginal rate of substitution for each of these utility functions. So let's start with our first example. We have the utility function u is equal to x to the 0.5 times y to the 0.5. So all we have to do to figure out the marginal rate of substitution is just calculate the marginal utility of x and the marginal utility of y, and then we'll take the ratio of those two. So let's start with the marginal utility of x. Remember, that's just the derivative of this utility function with respect to x. So if we look at our utility function, the derivative with respect to x would just be 0.5 times x to the negative 0.5. So remember the power rule from calculus, just take the exponent, move it out front, and then reduce the exponent by 1. So 0.5 minus 1, that's negative 0.5. And then we just have y to the 0.5. Then we can calculate our marginal utility with respect to y. So that's just going to be, we'll take our exponent and move it out front for the y. So we get 0.5, and then we have x to the 0.5, and we'll reduce this exponent by 1. So that would also be y to that negative 0.5. So lastly, to calculate the marginal rate of substitution, we're just going to take the ratio of these two. So we get marginal rate of substitution is equal to, so we'll have the marginal utility of x in the numerator, so let's write that. And in the denominator, we'll have the marginal utility of y. Now we'll notice that these 0.5s cancel out, and when we have a negative exponent like this in the numerator, we can make it positive by moving it to the denominator. And similarly, when we have a negative exponent in the denominator, we can make it positive by just moving it to the numerator. So when we do that, we'll have y to the 0.5 times a positive y to the 0.5. So that's just y to the first power. So in the numerator, we'll have y, and in the denominator, we'll have x to the 0.5 times x to the 0.5. And again, we just add the exponent, so that will just be x to the first power, or just x. So our marginal rate of substitution will just be y divided by x. That's the marginal rate of substitution given this utility function. All right, let's try example number 2 now. We're given the utility function u is equal to 5x plus 2y. So again, let's start out by calculating the marginal utility of x. So that's simply the derivative of this function with respect to x. So in this case, that would just be a 5. So the derivative of 5x is just 5. It's the coefficient out front. And because we're taking the derivative with respect to x, we can just drop the y entirely. Now in the previous example, we didn't drop the y because it was being multiplied by the x. But in this case, when we're adding the y, we're able to just drop it entirely. And then we can calculate the marginal utility of y, which is simply going to be 2. So the derivative of 2y is just 2. And again, we don't have to include the x term because we're adding, we're not multiplying. So this one is pretty straightforward. The marginal rate of substitution is just going to be 5 over 2. So this is our marginal rate of substitution. And now let's consider our very last example. We have the utility is equal to 10x to the 0.5 plus 5y. So let's start by calculating the marginal utility of x. So that's the derivative of this function with respect to x. So that would be 0.5 times 10, that's 5x. And then we have to reduce this exponent by 1. So 0.5 minus 1, that's negative 0.5. And again, because we're adding the y in this case, we can just drop that term entirely. Then the marginal utility of y, so that's the derivative of this function with respect to y, which would just be 5. So we get 5. Then the marginal rate of substitution, that will be the marginal utility of x divided by the marginal utility of y. And when we do that, we see that the 5's will cancel out, and we're just left with x to the negative 0.5. So if we'd like, we can make this exponent positive by just bringing it down to the denominator. So we would end with 1 over x to the 0.5. So this is our marginal rate of substitution given this utility function. So those were just 3 different examples of how to calculate the marginal rate of substitution when you are given the utility function.